A source IP can be used in multiple ways, such as for security measures and troubleshooting. Understanding the journey of your data, especially its source IP, is like having a roadmap in the complex landscape of network traffic, but preserving the original source IP is difficult. To better understand why source IP changes, let's examine a scenario. When a request hits a service, it then enters the Linux network stack. Here, Source NAT, implemented by Kube-proxy, changes the source IP, making every request appear as if it's coming from the Kube-proxy, complicating traffic distinction and security troubleshooting. We want the pod to see the original source IP, but that doesn't happen in iptables mode. Why is that? If you are determined to preserve the source IP address while using the standard Linux data plane, you can use components such as ingress controller in front of your workloads. You could use an ingress controller to attach the source IP as an HTTP header, yet this requires application modifications and introduces latency. If you are wondering why you have to modify your applications, it is because the IP address is expected to be viewed in the remote adder field. While it is possible to rewrite that HTTP field, in most cases we use other headers such as xforwarder4 to comply with HTTP standards. So, is there an easier approach? I'm glad that you asked, and yes, there is. Enter the Calico eBPF Dataplane. The Calico eBPF Dataplane has the ability to replace the Kube-proxy in your cluster. It implements a blazing fast service implementation via eBPF programs, delivering them without altering the source IP. Imagine the previous scenario, but this time we have enabled the Calico eBPF Dataplane. A request comes into your cluster doorstep. Calico eBPF programs that are injected into the Linux kernel will intercept that request in the earliest possible point. Next, it will use the eBPF service implementation to efficiently determine its destination. From there, another eBPF program will usher the request to the workload without touching the source IP address in any of the steps. Unlike the traditional method, Calico eBPF operates without Kube-proxy, streamlining resource use and enhancing efficiency for handling high-traffic workloads. In essence, Calico eBPF not only preserves the source IP without additional ingress controllers or application changes, but also offers a more resource-efficient alternative to Kube-proxy. Calico eBPF Dataplane implements Kubernetes services by utilizing the power of eBPF programs. It gives you the ability to preserve source IP preservation without the need of any ingress controller or change in your application. It completely replaces Kube-proxy and provides a more efficient way to handle high-traffic workloads environments with less resource consumption. Interested in diving deeper into Kube-proxy and traffic handling? Discover more in our free Calico Operator Certified course. Scan the QR code to begin your journey.